My name is Oege De Moor. I'm the VP of GitHub Next, the team at GitHub that created GitHub Copilot in very close collaboration with the team at OpenAI. I'm delighted, therefore, to have two of the members of the product team at OpenAI with me today. And Angela and Katie, perhaps you can introduce yourself.
Hi, I'm Katie Mayer. I work at OpenAI, where I manage our partnership with Microsoft. In particular, I led OpenAI's development effort on Copilot in partnership with Oege.
And I'm Angela Jang, and I'm a product manager at OpenAI, and one of the products I work on is Codex.
Okay, so just to frame the discussion that follows, perhaps for the audience you can explain what Codex is, what makes it special, and why should people be excited about it?
Yeah, so Codex is OpenAI's AI system that helps to translate natural language into code. As an AI sort of generative model, it has a lot of capabilities, but we find that it's really particularly strong at tasks like program synthesis, code translation, and code documentation. So what really makes Codex exciting is that it actually expands programming. What I mean by that is that it sort of breaks down some of the barriers to entry to bring code and programming to new industries, new problems, and more impactfully, new users.
Yeah, and building off of that, right? We knew that like Codex would have all of these cool capabilities when we saw them in the model, but what we've been validating over the last couple of years is really the impact of those capabilities and where they provide value. And yeah, I think it's right where Katie said, which is lowering that barrier of entry for people that want to write code, but then also making the job of seasoned software professionals easier too.
Okay, so most of us here know about the applications of Codex to Copilot. If you were at the keynote this morning, you know of the application to Hey GitHub. What are some other applications? What are people building with Codex today?
Yeah, because when people know about Copilot, they think of kind of that like latter case that I mentioned, which is using Codex as a software professional. But what we're seeing most, I think, in like the startup environment is actually using it as a low-code tool to just generally provide more access to coding capabilities for a broader audience. So one example there is this tool called Flutterflow, which is a low-code tool to build UIs using Flutter, which is Google's open source software. So what you can do is you can actually use like a drag and drop UI to build out your interface. But of course, then you run into limitations because there's only so much that you can do with a UI. And so then what they do is they extend then your capabilities with Codex to allow you to add custom functions. So we actually prepped a quick demo, if I can get this to work, of it working. Yeah, so you can see here actually, this is the UI that you're using to drag and drop typically to make code. But then when you run into a blocker, you can come and put in, what your custom function should be, maybe a couple of lines of what you want it to do, and then it generates actually the code that you can use directly in your application. So this is pretty cool because the makers of Flutterflow are talking about when people needed to use this or needed a custom function, usually they would have to go and do like communities to see what they have built, start learning the language more themselves, and it was just a really slow process, whereas with Codex now it's one of these examples where they can actually start to do it with less grasp of the language. And yeah, so that's just one example, but we see this with like a lot of industries. I think one that we see a lot too is business analysts, because Codex seems to be really good, particularly at taking natural language and turning it into SQL code, for example.
Forget the business analysts. I will.
Yeah, everybody forgets like a semicolon or something. So SQL's like a finicky one that like Codex can offload from you pretty well. Like you can give it your schema, you can give it the query you want, like, oh, give me the last 10 users that signed up for my application and whatnot. It'll generate the SQL, you can run it, and then all of a sudden you have this nice like natural language interface for us, for business professionals, to then like query your database like really easily.
And we're seeing Codex applications to help to sort of break down the barriers to entry in other industries, right? Like education and even helping experienced software developers.
Yeah, definitely. Like, I think in education, there's maybe like 2 ways that Codex has been particularly impactful. One, like, I mean, you can imagine if you have now this like interface from language to code, now students can kind of see like example after example of like what their code might look like without having to, again, like deal with, you know, small syntactical details or like specifics of a new language they've never seen before. They can kind of see, okay, well, if I wanted to write something like this, this might be what it looked like, and have those examples over and over again. But Codex also works like the reverse way too. Like you can take code and turn it into natural language. And I think this has been like a particularly powerful tool for education, because you can take code and then you can just easily explain it. Like you can just highlight it and be like, what does it do? And it just explains it to you in natural language, which is illustrative.
So those are all really cool applications, and of course that has not gone unnoticed. The open source community has started several efforts to create open source models, very similar to Codex, also aimed at code generation. So as the originators of this movement, how do you think about those efforts?
Yeah, that's a great question. I mean, we're really glad to see these open source models actually enter and really expand the market. They help to bring some of the sort of benefits that Angela kind of just talked about of these models to an even broader audience, and that's just very exciting.
Yeah, and one of the goals of our org in terms of deploying these models is, you know, first and foremost to share those benefits, but also then to get feedback to learn, you know, how are these models really useful? Like we can kind of see that the model does well on evals, you know, it does well on demos. Maybe when we try it, does things that impress us. But really, where is the value that's going to last to end users is something that we're always trying to validate. And where does it come short? Like where is it failing in ways that are preventing it to reach those end users? And that kind of feedback is extremely valuable. So when we see these open source models and people building on top of them and doing cool things with them, we really love to get that feedback and validation too in terms of what's working and what's not.
So at GitHub, we feel exactly the same. It's only right that the open source community, the creators of the public data sets that go into these models, also build new ones and give feedback validating the basic assumptions that went into the original Codex, and see where all of us can do better and advance the science. In fact, one of the people who are leading this movement is sitting right here in the audience. We're very keen on working with you all. So we've talked about some of the stuff that's exciting and good, but it's inevitable that with a new technology like this, totally new applications, there's also some challenges. And one of the challenges that's being very actively discussed in the community is this phenomenon that sometimes you prompt Codex and then it will give you back a suggestion that's identical or very similar to an existing piece of public source code. So because of that, to some people, it gives the impression that Codex is just this huge database or snippets of code, and you give it a prompt and it will retrieve a snippet that may be close to what you want to do. So how should we think about this? Is it true? Is it a database? Or?
So that's a great question. I know that sometimes folks do think that these models are essentially copying pasting from a training data set, and that's just not actually how these models work. So thinking about what's actually kind of going on is that AI models, both for language and code, are simply trying to predict the token or character that comes next. So for code in particular, these AI models are actually generating entirely new code using kind of in a probabilistic way, basically on their end. The models are not actually kind of looking up snippets as they go. They're not pulling from a database of code, but just actually generating something new.
So from the very beginning, we were aware, of course, that there might be challenges of this kind. And it's because of that when we started building Copilot, we rolled it out in the stage-wise fashion. We first did the preview, specifically with the aim of engaging with the community and talking about these problems and the best way to, on the one hand, get the benefits that a tool like Copilot brings you, but also making sure that any of the disadvantages are mitigated. So for this particular problem, one feature that we built in that you can switch on optionally is to suppress any suggestion that matches a piece of public source code. So before the suggestion is shown to you, we'll actually look it up in an index of all the current public source code on GitHub, and if there is a match, it gets suppressed. So that has the advantage that then you're totally sure you will not inadvertently be quoting a piece of code from some repository that you don't know about. Of course, as soon as we did that, we also got feedback from people who said, well, but I wanted to have this very natural, normal suggestion. This is what I expect to see, because that's how every developer would have written that piece of code. So in discussion with the community, we've now come to the conclusion that it's best that we give a reference tool with Copilot, so that if you wish, with a suggestion, you will also get links to places where this something very similar occurs in public repositories, and then you can make your own judgment of whether you just want to accept the suggestion, or perhaps it's actually an indication that you shouldn't be writing that code at all. You want to build on what someone else has done and simply take that other code as a dependency of your own. This is currently it's a commitment. We're building this, but it will be a while yet before we can release it for everyone to use.
Awesome. So it's also been suggested that because GitHub Copilot learns from arbitrary public code, it might struggle with insecure suggestions, especially given your background and experience. I was really curious for your perspective on that. Is this true? How should we think about it?
Yes, so thank you for asking that question. It's very near and dear to my heart. So before I did Copilot, I was the CEO and founder of a company called Sebald, which is now GitHub Advanced Security. And I'm very keen that we stop all vulnerabilities at source. The first answer is that you should always carefully vet all the suggestions that you get from an AI like Codex. So treat it like a contribution from a junior colleague. It needs to be tested, it needs to be reviewed, and you need to run all the available tools to weed out potential vulnerabilities. If you do it with GitHub Advanced Security, many of your vulnerabilities will be caught. That being said, of course, we're working very hard to try and make sure that those insecure suggestions are not made in the first place. And on one hand, you can do that with better models. And thank you very much. We regularly get better models from OpenAI.
We do our best.
But it's also a matter of giving the right prompts. If in the prompt you already give instructions to write more secure code, chances are that that's what you're going to get. So we're working on that, as well as running very quick checks similar to what I said about the reference tool, to just suppress suggestions that have vulnerabilities in them. All right, so we've talked about overall how Codex is exciting and useful. We've talked about some of the challenges. Can we now talk a little bit about the future and
Yes,
what's going to happen? So how do you think that an AI will change coding? How is it going to change software development?
Yeah, so I mean, I think we're always working on making the capabilities better. And like you mentioned, being able to handle, more and more complex prompts, more and more reliability out of the models. We're also making it a better product, making it faster, more reliable to serve. And all those things, I think, is with the goal of just, again, unlocking more of that developer workflow. So being able to have Codex be a part of your workflow end to end. So from starting with brainstorming of design all the way to debugging or performance testing or documentation, like we want to be there kind of every step of the way, doing what it does best, which is, again, offloading those parts that you don't want to do so that you can focus on the creative parts. So integrating more into that workflow with better capabilities and a better way of serving the models is a big goal for us. And I think another goal for us is, again, just making sure that we unlock more industries for more potential developers here. So I think it would be super cool if we had developers like designers using these AI-assisted tools to be building mock-ups, musicians, like producing music with code because it's like easy enough to do so. I just think unlocking, that next, 100 million developers out there to see what they can create is really like the end goal here.
Yeah, and when I think about kind of the future of what an AI programmer could be, for me, and really enable, for me it's honestly fundamentally about focus. An AI pair programmer like GitHub Copilot really helps to enable programmers to focus on the most creative parts of their work, which honestly is the most enjoyable. We've seen this and saw this very, very explicitly in some of our earliest user studies that we did together on Copilot. But these technologies really help to sort of alleviate some of the boring elements of work. And instead, programmers get to focus on the creative aspects, like deciding what a piece of software should do. And so programming then kind of shifts, right? It becomes this design opportunity. You get to decompose very large problems into smaller ones and then even into smaller blocks from there. And sort of when you look at programming in that model, these AI pair programming technologies really are this very beautiful complement to kind of do those little details for developers. As I kind of think about where this technology is going and where really how quickly AI-powered tools are improving, you can pretty soon imagine a world where one day anyone, any human, really truly anyone, could really just design kind of in describing in either natural language or even diagrams what they want to build and see it come to life. And so that's kind of where I see the real sort of power of this technology, right? It enables developers to focus on bringing their creativity to life. And personally, I'm just really excited to see what this focus and creativity can actually help to build and bring to the world.
So actually, I'm glad that you mentioned focus. We already see that in user studies of Copilot today. My colleague Irene did a study of 2,000 users of Copilot. And what she found is that 74% of people say that it allows them to focus on the more interesting, satisfying parts of their work. And a whopping 98% said that it allows them to accomplish boring tasks faster. And so this is just the beginning. It's a first attempt, and we'll get much more of that.
Absolutely.
So in order to get there, what needs to happen? Well, how does the technology need to evolve?
Yeah, so I think one part is always going to be making the capabilities better. But we obviously serve these models via an API. And so one thing that we want to do is empower developers to create really cool applications on top of the models. Because developers are really the ones that are going to understand, how to integrate them in these models into the workflows of developers. I mean, GitHub Copilot is like the perfect example of this, of taking the power of Codex and really being able to distribute it to end users. So for us, we want to make that process for developers as seamless as possible, provide them with the tools to empower them to change, end users' workflows, and really start to, again, unlock those new developers and new parts of the workflow that maybe right now Codex isn't a part of.
I agree with that. I do think that programming is going to be much more about sketching a design, much like an architect would do it, and have the AI then take you by the hand and take each individual part of it and refine it further. I do also think that will be a much more conversational process. So today in Copilot, it's just saying you've got, you prompt it, and then it gives you an answer, and then you take it or you don't. You might ask for another one. But as you already saw in a very small way with the demo of Hey GitHub today, you can actually, it shows you a suggestion, and then you say change. No, I want you to change the result type to a Boolean, and it will make a quick edit. Like that, but in a much more back and forth fashion.
Makes sense. Yeah, and I really think that we can get there to a point where, even in that iterative state, you're going back and forth with Codex and just having more integration points. And I'm curious what you guys think in terms of the impact then broadly on the AI workforce and the developer workforce once we kind of get more and more towards that future.
Right. I get asked about that a lot. Is the AI coming for our jobs? Yeah. And I emphatically think not. And the reason I think not is that if you look at the history of software development, it comes in big waves. The first big wave that I saw during my own career is that people started programming in much higher level programming languages. And that in itself, I mean, we've forgotten that now, but that in itself, people stopped programming in very low level languages and went to higher level programming languages. There was also a chorus of people who said, oh, surely that will, now there's much less work for software developers. Well, the opposite happened. More people could write software, and so more software, more creative ways of using software were invented. And then the second big wave, in my view, was the introduction of open source. And once again, now you don't have to build everything from scratch yourself anymore. Instead, you can build on the work of others. That reduces the amount of work that you need to do as a developer, right? Well, perhaps, but in fact, it enabled many more people to build many more interesting things because the standard components that everyone was implementing over and over again for themselves could now be built on once and for all. And so the third wave, where I see AI coming in, it will do the same thing. We've talked about it, that it actually lowers the barrier. It lowers the floor for getting into programming, but it lowers the floor without lowering the ceiling. Many low-code applications today, they are easy to get started, but it's limited what you can actually do with them. You reach a certain level, and then you have to go and start programming again in a normal programming language that other experts use. The promise of AI, and what we're already seeing with Copilot today, is that you can actually use precisely the same tools, the same languages that the experts use. It's just easier to get started. And so I think that that's the message here, that by making it easier, there will just be more programmers, and the programmers will be able to focus on the creative part of their job. And we'll just see many more applications that we haven't even dreamt of today. So, is there anything that you were scared of in this technology?
Yeah, I feel like there's a lot to be excited about in the sense that, like, you know, there's a huge opportunity in front of us if we really think about unlocking just like unbridled creativity from like the whole fleet of software developers out there, and just seeing like what they could possibly build, what are like the new creatives that aren't in programming today going to build, you know, the designers and the journalists and the musicians of the world as examples. But I do think that like with this potential impact, there are concerns because, you know, obviously it's a fast-moving field. Anytime you deploy something with this kind of impact, then there are broader impacts outside of what you just deployed. So definitely at OpenAI, this is something that we think about a lot, which is the impact of every deployment and what that means broadly. So yeah, I think that's something, you know, to be nervous about just is, you know, being on the forefront of this kind of transformative change. But you know, we continue to learn, evolve from what we've seen, and just continue to be excited about the potential here.
So I also think that probably the biggest risk here for this type of technology is over-reliance. If you put this in the hands of inexperienced developers, it makes suggestions. It's very easy to hit that tab key, accept it without knowing what you're actually doing. And so we do need a much more conversational way of interacting with the AI, so that you can ask it for an explanation, ask it for test cases, making sure that the thing that is being suggested is actually truly what you want and need.
Yeah.
So talking about things that are a little bit scary, your company is aiming to build an AGI, a general artificial intelligence. So why are you investing in this code generation stuff? Is it just a side thing, or is it actually part of your mission?
Yeah, so really we are trying to build an AGI and make sure that we do that safely and deploy it or its benefits in a responsible way. Code generation is actually a core part of our research roadmap to get there. And largely that's because code actually embodies a lot of the kind of capabilities that we're interested in seeing from our models. So code becomes then a really interesting way of evaluating the model's performance against these capabilities. And in particular, code is great for checking if there are high-level reasoning and complex problem-solving skills inherent in the models. And so we can use that as a checkpoint to basically see if our models are improving. Additionally, code can be verified. That's incredibly helpful and practical. We can take a model's outputs or suggestions and actually check if they're right or we're on the right track simply by executing the code. And so basically what that enables for research is actually a really helpful and effective learning loop, which we then use to kind of continue to push the boundaries of our model's capabilities today, and then check it as well as sort of this waypoint along that journey. Finally, and I'd be remiss not to note this because Oege is very familiar during our development of Copilot, but we've also seen this technology just actually accelerate our own team. And so it really does help us kind of get to our mission and make progress against our mission faster when our team, which consists of software developers and AI researchers and others along the way, are actually accelerated in their own productivity. And so I think when you look at all those kind of different elements of code generation, it really speaks to why it's valuable as part of our research roadmap.
Very cool. We're almost out of time. I would like to encourage everyone to go and see the 3:30 keynote by Codex, where there will be several other new applications of Codex on show. But you at OpenAI, what's the what's new? What applications are you excited about?
Yeah, so I know we're almost out, but wanted to just quickly kind of cue in a little bit of what's to come and where we're making our kind of Codex models and capabilities iterative. So now our latest Codex prototype can actually explain its code and debug its own code, and then actually learn from its mistakes and correct them all on the fly. And so we wanted to show you sort of a quick demo today that basically walks through us giving Codex, the model, a very simple problem, a data parsing problem, and that's it. And we'll see how Codex approaches the problem from there. So I'm just going to...
Oh, it looks like we need to pull it back up.
OK, thank you. You want to just click play on it. Great. So we've given Codex the problem. That's it. From here, you'll see in a second that Codex is actually going to outline its approach in natural language. From there, it's going to start to move on and step by step sort of generate the code it needs, review its code, and then, if it's correct, move on to the next step. From there, it's going to kind of integrate each of these components into the actual function that it needs to create. And then it's going to try and evaluate itself again, this time by writing tests. So as Codex goes, and you'll see this in a second, but it will discover from its tests a slight bug. And so it tries to learn from that mistake and actually iterate and correct itself, and then evaluate to confirm that it's right. So here, basically, what you're seeing in this very brief demo, you're actually seeing all the sort of capabilities of Codex come together, right? It can now not only sort of explain its code in natural language, generate its own code, but now correct itself all on the fly and in real time. So personally, I'm really excited to see how these new capabilities will advance and take us to the next evolution of an AI programming tool.
It certainly will. Thank you very much.